So does cosine of 30 degrees plus 60 degrees equal cosine 30 plus cosine 60? Let's find out. So we can go ahead and combine like terms. So the left side is really looking for the cosine value of 90 degrees. And we know that. What is the cosine value of 90 degrees? The top of the unit circle. What's the cosine value? It's 0. Good. All right. So the left side of this equation, 0. Let's see if we get 0 to be the answer on the right. So cosine of 30 degrees is the smallest angle. So cosine 30 is pi over 6. And cosine for pi over 6 is root 3 over 2. Cosine of 60, that's pi over 3. So that's going to be root 3 over 2 plus a positive 1/2. And 1 plus root 3 over 2, that of course does not equal 0. So no, that is not the same thing. So if that's not the same thing, guys, we're going to have to use these identities. So please remember, these identities are provided. You do not have to memorize these. And they're just useful tools for us to be able to verify, for us to be able to simplify, for us to be able to solve equations. So just make sure you remember, guys, this is going to be row 1. This middle row is row 2. And then, of course, the tangent is row 3. So I'm just going to be referring to these rows because it's about to be off my screen when I start doing my work. Row 1, row 2, row 3. All right, here we go. So we are going to verify. So in order for me to verify, I need to understand what I'm looking at. I know that I'm looking at a cosine sum identity. I also need to recognize which side of the equal sign it's on. If you notice, there's parentheses. All of my identities have parentheses. They are all on the left-hand side of the equal sign. Everything on the left-hand side of the equal sign is condensed. When you see parentheses, it's considered in condensed form. On the right-hand side of the equal sign, it's considered expanded. So the other side over here on the right is considered expanded. So if I'm trying to verify this and make the left side look like the right side, I'm going to focus on the left side and I'm going to start expanding this out. When I expand this out, I am going to use the top row under the sum identities. So look at row 1 where it says the sum identities. It is going to be cosine A times what? What's after cosine A on row number 1 under the sum identities? What's next? Here's row 1. Here's where it says sum identities. We're going to write the expanded form. There's cosine A. What is cosine A being multiplied by? What is this right here? Cosine B or cosine beta. So I'm going to draw a blank for that. Then I'm going to recopy the minus sign. Now I'm going to draw a blank for sine alpha or sine A. And remember that's being multiplied by sine B, sine beta. All right, so just remember cosine alpha times cosine beta minus sine alpha times sine beta. We're just going to plug in some stuff here. We're going to plug in what we know, leave out what we don't know. I need cosine for alpha. Guys, remember the very first term in the parentheses is alpha. After the parentheses is beta. So do we know the cosine alpha? Do you know the cosine value for pi? You should know the cosine value for pi. What's the value for cosine of pi? Yeah, that's right. Very good. That goes right here. Cosine beta is the cosine value of x. X is an unknown. I have no idea what that is. So that's going to be just whatever cosine x. Whatever that is, it's cosine x. Now let's talk about sine alpha. That's going to be the sine value of pi. What is the sine value of pi? It is. Good job. So 0 is going here. And sine beta is sine x. I don't know what that is. So sine beta is just going to have that unknown there. All right, let's do our little order of operations. Let's multiply these two and then subtract them. So when we multiply these two right here, negative 1 times cosine x is negative 1 times cosine x, or just negative cosine x. I'm going to recopy the minus sign, and then 0 times sine. 0 times anything is 0. All right, so negative cosine x minus 0 is negative cosine x. So now I'm ready to bring down the equal sign and then the right-hand side, which is verified. So remember, guys, this started out in condensed form. This one is starting out in expanded form. So if it's expanded, I'm going to put it back together. Whatever it is, you work on the other side of the equal sign for your identities. This starts in cosine, so I know it's going to be row 1. This is cosine times cosine plus. Cosine's always opposite, so this is actually a difference identity. All right, here we go. So this is going to be alpha. 2x is going to be beta. I know it's a cosine subtraction identity. I'm just going to drop in alpha and beta. I know alpha is 3x. I know beta is 2x. I can combine what is in the parentheses. So this is going to be cosine x, and that already equals cosine x. So listen, when it comes to putting it in condensed form, it is so straightforward. Don't overcomplicate it. If you're going to condensed form, it's very straightforward. That's it. Just put them together. Any questions on number 2? Let's look at question number 3. Question number 3 says to simplify. Well, I can't simplify really anything yet. I know it's in condensed form. I'm going to try to expand it. So here we go. When we expand sine, remember sine's a little different because it mixes up the trig values. This is going to be sine A times cosine B minus cosine A times sine B, or sine beta. So we're going to plug in what we know here and just kind of figure out what to do next. So remember, pi over 2 is alpha, x is beta. I'm going to draw my little template to put in my blanks here. All right, here we go. Sine alpha is going to be sine of pi over 2. Pi over 2 is the top of the unit circle. So sine of pi over 2 is 1. Cosine of beta would be cosine of x. We have no idea what that is, so that's going to stay cosine x. All right. Cosine alpha will be cosine of pi over 2. That's going to be 0 because that's the top of the unit circle. Sine beta is going to be sine x. All right, we're just going to do our terms here. 1 times cosine x is cosine x. 0 times sine x is 0. So the value of this simplified is cosine x. And then real quick, guys, you don't have to flip back, just look up here. your cofunction identity, that was this expression. Notice how we ended up with an answer of cosine x that verifies that cofunction identity. Okay. Let's look at the bottom. All right. So, one more time. When you are writing something condensed, don't overthink it. Write the expression as the sine, cosine, or tangent of a single angle. So if you notice, this is an expanded form. We're going to write it back in condensed form. So this is an expanded. We're going to take it to condensed. It starts with sine, so I know it's going to be a sine identity. Remember, the sine value is going to be a difference identity because it has a minus sign. Alpha is the first angle given, so it's going to be 100, minus beta, the second angle given, which is 15. So just 100 minus 15, that's all it is. So this is going to be sine of 85 degrees. Write the expression of a single angle. Boom, there you go. That single angle is 85 degrees. So usually we don't really deal with degrees, but y'all, if it starts in degrees, then our answer needs to be in degrees. So that's it. That's going to be the answer for number 4. That's a single angle in degrees. If you look at number 5, it's also in degrees. Number 5 deals with tangent, so I know it's going to be row 3. If you look at the numerator is going to tell you whether it's a sum or a difference. It is for sure a sum identity because it's being added. Y'all, alpha is 36, beta is 15. So for this one, it is going to be tangent of 36 degrees plus 15 degrees. So the single angle is going to be just 51 degrees. That's it. Because it has a minus sign in it. So if I'm ever trying to find anything, I just start trying to put it in the other form. Both of these are expanded. I'm going to try to put them in condensed and see what happens. So this is going to be cosine, and then it's going to be alpha plus beta. Alpha is the first number, beta is the second number. So this is going to be cosine of 110 plus 130. So we need to find the exact cosine value of 240 degrees. Now, I don't know about you guys. If y'all have that cosine value memorized, that is so awesome. I just have them in radians. So remember, this is kind of how I back into it because I don't have the radians memorized for 240. But I know that if this is 60, this is 120, and this is 240. So these are all in increments of 60s. 60 is pi over 3. 240 is 2 pi over 3. I'm sorry, 120 is 2 pi over 3. So what is 240? It's over 3. But it's in quadrant 3, so what's the numerator? Yeah. Do y'all know the cosine value for that? Indeed. Good job. That's going to be the answer. They wanted exact value. Boom. There it is. Okay. Next and final example for today. This is an expanded form. I know for sure it's a sine property because it starts with sine. It is going to be a subtraction property because sine doesn't change. So we need to find the sine value of 5 pi over 4 minus pi over 12. And you are going to have to find the LCD. Y'all remember to find the LCD when it's just numbers. It's just the least common multiple. 4 goes into 12. How many times does 4 go into 12? So we're going to take this fraction, multiply by 3 over 3. So this is going to turn into 15 pi over 12. Now I can subtract regular pi over 12. So 15 pi over 12 minus pi over 12 is 14 pi over 12. That can be simplified. What does that simplify to? Yeah, that's on the unit circle, guys. What's the sign value for 7 pi over 6? What's the y coordinate for 7 pi over 6? It's the same. It's -1/2. It's -1/2. That's right.